What's up guys, this is Massey. Welcome to another video. In this video I want to talk about dot product of two vectors. Let's start with an example. Here it says find the work performed. Max is pulling his sled up a hill with a force of 120 Newton at an angle of 20 degrees to the surface of the hill. The hill is 100 meters long. Find the work that Max performs. So here we have a triangle. We need to find out, we have two vectors, AB, and then we can find out the magnitude of AC. There are two vectors to consider. One of them is force on a sled and the displacement S along the hill. To find the work, we need to find out the magnitude of the component force along the surface of the hill. So it means that we need to find AC in here. So when you consider 20 degrees, AB is the hypotenuse and AC is the adjacent. So when we have cosine 20, we can say cosine 20 equals to AC over AB. We know the magnitude of AB, which is equal to the force magnitude, which is 120. And based on that, we can find AC. So AC over AB equals to cosine 20. So AC equals to AB times cosine 20. 120 times cosine 20. So work would be 100, which is the displacement, and AC, which is 120 times cosine 20. The final answer is going to be 11,276. The work done by Max in pulling his sled up the hill is 11,276 joules. Let's define dots product. The dots product for two vectors A and B is defined as A dots B equals to the magnitude of vector A times magnitude of vector B times cosine theta, where theta is the angle between vector A and vector B when the vectors are arranged tail to tail, and theta is between 0 to 180 degrees. The dot product is scalar, not a vector, and the units depend on the application. So remember, the answer to dot product is a scalar. It's not a vector, it's scalar. If either A or B is 0 vector, then the dot product of AB is 0. It means that if the magnitude of A or the magnitude of B is 0, the dot product of these two vectors for sure is 0. Now let's see this example for dot products. Determine the dot product for each pair of vectors. Let's see one by one. Part A, we have two vectors. The magnitude of A is 20, the magnitude of B is 30, and the angle between these two vectors is 40. So that's going to be very simple. So the dot product between A and B is going to be the magnitude of A times magnitude of B times the cosine theta, in this case is 40. So it's going to be 20 times 30 times cosine 40. So as you see here, it's going to be 20 times 30 times cosine 40. That will be for 59.6. Again, as you see here, we are dealing with a number. The answer is going to be number, not vector. Part B, we have vector M, 60, and the vector N, the magnitude is 75, and the angle in between is 90 degrees. So it's going to be 60 times 75 times cosine 90. Cosine 90 is 0, so the whole thing is going to be 0. So whenever we have two vectors perpendicular to each other, the dot product is going to be 0. So we can say the dot product of two vectors are 0 whenever we have one of the vectors to be 0 or we are dealing with two perpendicular vectors. Let's see the last part. We have vector C. The part C is going to be vector V and vector U. Magnitude of U is 100, magnitude of V is 85. And the angle between these two is 120 degrees. We are dealing with obtuse angle. So it's going to be 100 times 85 times cosine 20. The answer is going to be negative 4250. Why is negative? Because cosine of an angle greater than 90. So whenever the angle is between 90 to 180, the cosine is negative, as we know from trigonometry. So that's why the answer is negative. Let's see the properties of a dot product. For non-zero vectors u and v are perpendicular if and only if u dot v is 0. That is, if u and v are perpendicular, then the dot product of u and v is 0. And if dot product of u and v is 0, then u and v are perpendicular. 2. For any vectors u and v, the dot product of u and v equals to the dot product of v and u. This is called the commutative property for the dot product. Commutative property. C. Or number 3. For any vector u, u times u is going to be the magnitude of u to the power of 2. Why? Because it's going to be the magnitude of u times the magnitude of u times cosine 0, because we have the same vectors, and the angle between the same vector is going to be obviously 0. So cosine 0 is 1, so that's why it's going to be magnitude of u times magnitude of u times cosine 0, which is 1. That's why it is magnitude of u to the power of 2. 4. For any vector u and v and scalar k, we can say k times u times v equals to k times the dot product of uv, or you can say dot product of u and kv. This is called associative property for the dot product. Number 5. For any vector u and v and w, u dot v plus w equals to u dot v plus u dot w. And because of the commutative property, v plus w dot v u equals to v dot u plus w dot u. This is called distributive property. Next example. Use the properties of the dot product to expand or simplify each expression. Part A. Ku and u plus v. The dot product of ku and u plus v. So we can say we have ku times u plus ku times v. U dot u is going to be u squared, and then we have k times u times v. That's how we expand it. The second part, we have r plus s, r minus s. So the dot product of r plus s and r minus s. So it's going to be distributive property, r plus s dot r plus s dot negative s. So when we distribute it, it's going to be magnitude of r squared minus magnitude of s squared. Let's see next example. Calculate dot products of vectors. Calculate the dot product of u and v. We have u and we have v. So the dot product is going to be u1 v1 plus u2 v2. So 5 times 4 is 20. Negative 3 times 7 is negative 21. So it's going to be 20 minus 21, which is going to be negative 1. Part B is going to be u equals to negative 2, 9. V is going to be negative 1 and 0. So it's going to be negative 1 times negative 2 plus 9 times 0. That will be positive 2. Next example. Prove a dot product property. Use an example to verify the property that the dot product of A equals to magnitude of A to the power of 2 for any vector. So we can say, for example, we have 2 and 5. 2 and 5 and 2 and 5 is going to be 2 times 2 plus 5 times 5. That will be 4 plus 25, which is 29. On the other hand, we have magnitude of A to the power of 2. So it's going to be square root of 2 squared plus 5 squared to the power of 2. The power of 2 and the square root cancel out. It's going to be 29. So left hand side and right hand side are equal. Part B, it says prove the property algebraically. We have a1, a2. Again, we can do the same thing. a1 times a1 plus a2 times a2. That will be a1 squared plus a2 squared. On the other hand, right hand side, we have magnitude of a squared, which is going to be square root of a1 squared plus a2 squared to the power of 2. To the power of 2 and square root cancel out, and then we have a1 squared plus a2 squared. So the right hand side and left hand side are equal as well. So that's proven algebraically as well. So let's wrap up and summarize what we learned here in this video. The dot product is defined as A dot B equals to magnitude of A times magnitude of B times cosine theta. Theta is the angle between A and B, and theta must be between 0 and 180 degrees. For any vectors u, v, and w, and a scalar k, when u is not 0 and v is not 0, they are perpendicular when the dot product is 0. So if we have two vectors perpendicular to each other, the dot product is going to be 0. Then we have commutative property, which is the dot product of u and v equals to the dot product of v and u. The dot product of ku times v equals to the k times the dot product of u and v, and equals to the dot product of u and kv. After that, we have distributive property, which, as you saw, is u dot v plus w is going to be u dot v plus u dot w, and v plus w dot v equals to v dot u plus w dot u. And the dot product of u and u is the magnitude of u to the power of 2. Vector u times 0 is going to be always 0. And if vector u is u1, u2, and vector v is v1, v2, then we can say the dot product is going to be u1, v1 plus u2, v2.